Hello viewers, this is the second video I promised with the second aircraft instrument. That's the Honeywell, how it is called, it's RDI, Radio Direction Indicator. It is part of the navigation computer system of a DC-10. And you can see its big display here. It's only the display interface of that navigation system. How it is working? You have on all places over the country you have navigational transmitters. You know where they are. They are drawn on the maps, and you choose a transmitter on your overhead panel somewhere, and then this needle here shows you the direction to that transmitter. The part in the middle here can deviate to the side. It tells you how much you are off. If you are on a parallel course to the ideal direction, this tells you how much off the course you are. Then under this black cover here, ground speed, it tells you how fast you are in regard to the ground. It's different from the airspeed you have, so airspeed and ground speed can be quite a difference. Here on this side, also under a black cover, you can see the miles you have to go to this specified transmitter. And then well, I'm not too familiar with this type of instrument, so there are a lot of items I don't know what they mean, but that's basically what it is. Now, to open it, normally it is sealed here. Most of these aircraft instruments are watertight, airtight, so that no moisture and no dirt, no dust gets inside. And oops, that's the connection for the illumination. It's already plugged out. So as you can see here, it's more like a precision watch than an aircraft instruments. You have all kind of synchronous motors, all kind of gears here. Most parts are driven mechanically, so of course you have a pointer that rotates, telling you in which direction you have to fly. That's the pointer that shows you how much you're off your course. This one doesn't move, but it could also be that it is possibly broken because it has a rough time. So that slider, if we slide that down, you can see the numbers. And here we have the same type of electromechanical numbers as on the instrument I disassembled before. So if we can look at this a little bit closer. Oops, that's too close. You can see there is a bunch of cables coming from each Rotary number display. I don't know how this is called. They are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 cables, 12 wires coming from each. So I think there is one wire for each number. Oh, and there is also a minus sign here, so that's the 11th cable. So you can also display a dash. This one looks, it has hit a little bit hard. That's a little bit out of shape. Oops, I have to adjust the camera. Where are we? Here. So this doesn't, well, it does, no, this one is it. So I think we can take this one to disassemble, because it won't work anyway anymore. There's also something very wrong here. It doesn't move too good. Okay, let's take out these indicators. Well, I thought this time I leave away all the disassembling action. The last video got a little bit too long. It was 1.5 hours almost. So I think I show you step by step what I'm doing and make the video a little bit shorter. Okay, let's see what we have here. Some nice indicators. What does it do? Not much visible on the front. That one turns the compass rose. This one does. This one turns that little triangle pointer. Okay. There's also something here that looks like a movement in a voltmeter, and that moves the central pointer here. So I assume that it must have some slip ring contact somewhere. Where could they be? Oh, they are here. Very nice. I hope you can see that in the darkness here. Let me play with my light. Yeah, I think you can see it. It's exactly here, the contacts, and also the movable contacts that turn around. So there are quite a lot of moving contacts here. I don't know what they are all for, but probably we will see that later. There is also a small motor here that drives this little gear here, and all this does is to move that heading indicator out of the way. That will probably tell you if your heading is not correct. It flips that over and you know, okay, I shouldn't rely on that value. There is another motor, electromagnet or something. It tells you true or mag, so that means this compass rose is either true north or magnetic north. As you know, the magnetic North Pole is not exactly where the North Pole geographically is, so there is a little difference, and you have to indicate that. So I have taken one out. It was quite easy, so I show you how these displays are attached. I hope on this side it's the same. There is one screw here and one screw down here. So that broken part here comes off. That's the shutter, which is quite a bit bent. I don't know what happened here. I know that one time this instrument have fallen down. So there is a short wire here that goes to that motor that actuates that shutter flap. So I cut these here, and then the entire block comes out. So there's a very nice cable tie here. It's all hand tied, hand wrapped. So this comes down here. And then on the electronic side, oops, there are 3 plugs that plug into this back panel. So this is a little bit more difficult because this part here is in the way. So I just want to show you how this looks like. So we have these plugs here. These are actually the dip sockets or dip connectors. You see this? I think they are most probably hand soldered into place. So that's the first, that's the second one. Oh, now it comes out the third one. So we have one connector for every digit. Yeah, let's see. The broken one here has quite a dent, so it is fallen exactly on that rotor here. That's not a problem because they can be separated and they can be used individually, which I will do now. Since this is a American made instrument, all the screws are of course in inches and, well, how do you call that, imperial measures. So I don't have a fitting hex screwdriver, but it seems that Torx 7 fits very well to these screws here. So a Torx is, if it's necessary, a good replacement for a hex key, for an Allen key, however you call that. So let's fiddle that through. Okay, so we have that motor separated. It's just a small motor. What do we have here? There is something written on the back. It tells me Faulhaber, made in Germany. Okay, that's a very famous company that makes micro motors and also bigger ones. So that's the broken one. let's remove that from the rest. Okay, so that's the other ones. As you can see, you have 0 to 9, a minus sign, and then you have 12 wires. I hope they are coded in the international color code, so black means 0, 1, 2, 3, 4, 5 to 9, gray and probably white could be the common. Okay, we will see that. So let's see what's inside here. So that's the broken one. It doesn't look too good. Probably I could fix it, but I don't want. I want to disassemble it. Let's see how that works. That looks like a rubber ring here. O-ring. I need some of my tweezers. Where's my camera? Here. So it's a very soft rubber O-ring. It's just hard to get underneath as it jumps around. So okay, that came off. I assume that now the whole wheel here comes off, probably. If I haven't scratched it too much now, that could be a reason to jam. Okay. Oops, what's that? So that's only a bit of plastic here with the numbers on it. Here we have something that looks like a magnet. Oops, now it jams completely. Why is it not turning? I don't know. Maybe that's more than just some plastic. Okay, here the part in the middle that turns. Okay, so we have a magnet over here and the center part, which I ripped out here. So I went a bit brute force on this. So here is the connection block. As you can see, there's some sort of PCB. There are two PCB tracks here that go underneath that here. And then if we look a bit closer, we can see inside there are pole shoes for every single number. So I think there's not much more than a coil around these poles to attract the corresponding number. So it's quite easy to understand how it works. So maybe someone is interested in seeing some manufacturer logos. It's NTI, it's the same as in the other instruments. I think that's possibly the only manufacturer of this kind of display. Date code is, no, that's not the date code, 39. So date code here is 8439, okay. That's the serial number. It's written. I should read the letters, then it's easier. DS11001, I think that's the type of this thing. Yeah, let's play with it. So why I'm so focused on this this place is that's the reason why I wanted this this unit, because I have the plan to build a little bit something with these rotary displays. So I finally figured out how it works, so I want to show you. The silver conductor here seems to be the common. I use it as ground. Let's see if it also works the other way around. -0. Okay. I think positive on the common makes a little bit more sense, but it also works the other way around, but it doesn't show you the same numbers. So I figured out, okay, I hook it up negative on the common, so I can show you what I found. White is number 4, as you can see here. 4. 5 is black, 6 is brown, and so on, 7, 8, 9. And as you see, when I remove the power, it spins free, so you have always to apply some electricity here. 8, 9, dash, 0, 1, 2, 3. Now it's a little bit weird, because I thought that black could be 0, brown 1, red 2, like in the resistor code, but it seems it is a little bit different. When I hook up the positive to the ground, to the common, let's see, white is 9. That makes sense. Black is the minus sign. Brown is 0. Red is 1, so we are 1 behind the color code. Blue is 4, 5, 6, 7, 8, 9. Okay. Well, I think you can do it either way. It would be a little bit more logical when positive is on the common. So it's very easy to make that run. 0, 1, 2, 3, 2, 1. So even if I choose just random numbers, 8, dash, 1, 9, 4, it just jumps to that number, which is very nice. A mechanical display that is very easy to interface to something. Okay, that's that. So for all those who are interested in the details, that's what I found. So as I said, I have negative as the common, which is probably not correct. So if you take positive as a common, you get a more logical way of working. One thing is for sure, the silver wire, or the transparent wire, however you want it, is the common, and all the others are easy to find out because you have a display that tells you which one is which. By the way, I set my power supply to 8 volt that gives me a current of about 80 milliamps, which is enough to turn these numbers. I tried it with 5 volts, 50 milliamps, which is a little bit too weak. Maybe 12 volt could also be okay, I don't know. I have not found any technical details. So maybe I better start with this part of the case, which comes off after removing many screws around here. We see here some multi-board construction with these huge connectors. So there is the back plate with the connectors and some big transistors here, power regulators maybe. They use the whole thick aluminium back plate as a heatsink. Then all the cables go up in this cable loom here. So we can remove that one, which has a rubber attached to it to keep the boards in place. And I hope we can just remove the boards. Yes. What do we have here? Date code 84 LH4626 and 4626 and glasses UA14BD. Well, you can read it for yourself. Have a look at it. It looks great. Great old school through hole technology. On the back side, not much exciting. Some coating on it. Well, maybe not. If then it's relatively thin. So, next board. There is some coating on it. Have a look at it. You can see the chips. It's mainly, I think, analog stuff, maybe some logic gates, but certainly not a microprocessor or something, because that stuff is in another box in the flight data computer. So, what do we have here? Oh, that looks digital. A lot of CMOS chips, CD40001 and brothers, CMOS gate logic with some probably driver transistors for all kinds of motors and solenoids here. Also, not much on the back except 2 Bosch wires. So, and then there is another board which is a little bit more interesting. As you can see, there are aluminium strips under the chips. They go to the frame here. They are for cooling the chips. So they have the cooler underneath the chip instead of gluing it somewhere on the chip. It does the same function. It takes up the heat and guides it to the frame here. There are also, well, these are a little bit more no, SN. I just think that's some gates and looks a little bit like TTL stuff. And here on the side you can see that's the sockets where these rotary indicators were plugged in. You can see them on this side, perhaps. Here the golden contacts here. So I'll show you how to remove that backplane board here, which seems to be, there are 4 screws, and if they are removed you can plug out this one. I hope so. Yes, I think that's the way it works. You can see it coming here. No. There are more wires on this side. Okay. I thought it was easy, but it isn't. It's never as easy as you think. Okay, some rubbery mess here. So I think I make it simple. Look away if you don't like it. 1, 2, and off we go. So let's look at the backplane board. 1, 2, 3 boards, and here the 4th board, which is still inside. There is a whole bunch of capacitors down here. Not sure if you can see that, it's a little bit dark. They look like precision capacitors. So what do we have here? Not much. Some test points probably, or just some wire solder points. So you probably can see the caps in here. And the rest of it is just connection. No, there is more. What's that? There are tiny little PCBs with 1 or 2, it looks like a resistor, which is glued to the back. So probably these are power resistors that need to be cooled. No, it's more, it's a transistor underneath. You probably can see that. You can see here transistor. Next to it was glued a resistor, so these are some smaller power transistors mounted into the back plate, which is very nice. Oh, and here we have the transformer with a couple of diodes around it. It looks like diodes, yes, I think so. So we have a transistor with its rectifiers mounted right here between the contact points. I'm not sure if this is just a power supply or some signal conditioning. So now we can have a closer look to this last board, which is the interface to the rotary indicators. There are a couple of chips on it. If you like to find out what it is, you can do so. Not much on the back side except the sockets. Yep, that's it. Now we have this one, and we see 1, 2, 3, 4, 5 synchro 2-phase 26 volts. That's a standard voltage, 28, 26 volts. This one looks like a stepper motor, but I'm pretty sure it is not a stepper motor, but it's more like a synchronous motor, which is used quite often in airplane instruments. As I explained in my last video, it's like a flexible shaft, but in an electrical way. So this motor here turns that pointer on the front. Then, okay, yes, here you can see, I think this one is the motor that turns this gear here, which turns the pointer in the front, and it also turns this synchronous sensor. It's in fact it's almost the same if it's a motor or a pickup sensor. They work in the same way. So this gives a feedback to the computer. So everything, yeah, mostly everything has an actuator and also some sort of sensor that tells the computer that everything is in the right position, to have a feedback for, because the computer cannot see the display, so it doesn't know when you start up the entire machine here. It doesn't know where this pointer is, so it has to have a feedback to know the position of this, and then it can adjust it to whatever is necessary to indicate the proper value. Okay, this one here turns the outer ring. There are two of these blue ones here connected together. That one is the center, okay. What is this? This is the small pointer, the triangle, which does also have a combination of a motor and a sensor here. I just call it motor and sensor because I don't know the exact technical term. So that one is nice. It's also a small motor with a gear and a section gear, and the only thing it does is to show you omega, INS or VOR, ILS. Okay, ILS is the instrument landing system. VOR is the VHF Omni range. So you have different types of navigation instrument in this one integrated. There is a red light that tells me alert. Let's see if we can make that light on. So I think I got it. There are two wires, very simple. Go to that contact point, and with 26 volts it shines up quite bright. Maybe I have to reduce that a bit for the camera. Yeah, alert, danger, you are going down. No, that's just for the navigational instruments. If something wrong with the navigation computer or whatever, that one will show up. And however, as a pilot you won't see that, because it means that you probably can't continue to fly, or you have to go back to your backup system, magnetic and true. I have already spoken about this. It's the North reference, magnetic North Pole or geographic North Pole, or the true North Pole. Okay, I think that's about it. A lot of mechanical gears. There is also an optical sensor which points down to this gear down here, which has a black and a silvery surface. Don't know if you can see that. There is another optical sensor. Yeah, here you can see the black and the silver half of this, which is certainly something like the maximum position. Okay, so what else do we have? Two little motors for the indicator, another little motor, so and another little motor that flips this heading flag here. There is an electromechanic movement for this pointer. This is like a movement of an old voltmeter. Here you can see the slider contacts that go to the rotating axle of this. Maybe I could use that for something else. You can see the contacts, very nice, probably gold plated, probably something else. Well, that's about it. Looks like a clockwork. Okay, thanks for watching.